Okay, guys. So today we shall see problems in two-port networks. Okay. So let us see the first problem. So here I have given, that is, you are asked to find Z parameters for the given network. Okay. This So for finding Z parameters, we are to find Z11, Z12, Z21 and Z22. For each of these parameters, we know the conditions. Okay. So to find Z11 and Z21, we will be open circuiting the output port. That means by open circuiting output port, I2 will become 0. So here in this problem, for easier understanding, what we have done is we have considered the clockwise current in this loop to be. Here we assume V1 is the voltage across this thing. So we consider I1 as the loop current in this loop and I2 to be the loop current in this loop. Okay. So now writing the mesh equation for these two loops, we will be having 2 I1 plus 1 I1 minus I2. Here as we have considered I1 and I2 as the loop currents, this will become I1 minus I2. That is equal to V1. So the first equation will be V1 is equal to 3I1 minus I2. And for the second loop, 1 into I2 minus I1 plus 2I2 plus 2I2. So that is equal to 0. So our equation will be minus I1 plus 5I2 equal to 0. So from this we will get I1 is equal to 5I2, and also we have V2 here as it is open circuited. V2 will be directly the voltage drop across this 2 ohm resistor. So this 2 ohm resistor, so V2 is equal to 2I2. So those equations we have written. Now substituting this 2 in 1, we will get the relation in terms of V1 and I1. So here the capital I1, the current entering the port, and the mesh current I1 are same. So we get V1 by I1 directly from that. So we get Z11 is equal to 2.8 ohms. Okay. Now for Z21 is V2 by I1. So for that, we have directly the equation, that is substituting this V2, I2 in this equation, we get V2 is equal to 0.4 I1, and therefore we get Z21 is equal to 0.4 V1. Okay. Next, to find the parameters Z12 and Z22, we have to open circuit the input port. So open circuiting the input port means you don't have this effect of this 2 ohm resistor. Here directly we have this thing. So let us consider the same way. Just for convenience, I have used this current to be I2 as it is, and I have considered I2, the capital I2 to be the anti-clockwise current over here. Okay. So with respect to that, we have the equation 0 is equal to 5I2 plus 2I2, because here in this loop I have this 1 ohm. So 1 small I2 plus 2 small I2 plus 2 small I2 plus capital I2. Okay. That is equal to 0. That's why the equation is 5I2 plus 2 capital I2 equal to 0. And in this loop, we have V2 as 2 into capital I1 plus, capital I2 plus small I2. Okay. So we have the equation V2 is equal to 2I2 plus 2 capital I2. So from this, we can also say V1 is, so here as we have open circuited, the V1 would be straight away the voltage drop across this thing when I am open circuiting the input port. So V1 will be directly 1 into I2. Okay. Minus 1 into I2 actually, because the with respect to the plus minus sign, the current should be entering in this direction. However, our small I2 is in the opposite direction. So you will be having minus I2. Okay. So now making the substitutions, we get Z22 as V2 by I2, and we get 1.2 ohms as the answer, and Z12 is V1 by I2. So we get the answer to be 0.4 ohms. So for this particular network, this is the Z parameter value. So here in this, actually we can find that Z12 and Z21 are same. So the network is actually reciprocal also. Okay. Next we shall see how to find the Y parameter. Okay. So this is the second problem where we are to find y parameter of the given network. So here what we do is we short circuit the output port to find y11 and y21. So short circuiting the output port means we will have V2 equal to 0. So redrawing this circuit, that is the first circuit you will be having. So I have short circuited over here. So this particular resistor is parallel to the short circuit, so this will not have any effect, so that gets nullified. And so our equation will be, so here considering I1 in the clockwise direction and I2 in the anti-clockwise direction, we have V1 is equal to 1 I1 plus 2 into I1 plus I2. So we have this equation. V1 is equal to 3 I1 plus 2 I2. And in the second loop, we have 2I2 plus 2 into I2 plus I1. So we will be having 2I1 plus 4I2 equal to 0. Okay. So from this we substitute and get I1 is equal to minus 2I2, or you could also say the other way, that is I2 is equal to minus 1 by 2 I1. Because in some substitution we will need both the cases, so we have written it. Now substituting this I1 in 1, we will get V1 is equal to minus 4 I2. So here I2 by V1 ratio is nothing but Y21. So we get the answer to be minus 1 by 4 more. And for obtaining I1 by V1, we substitute this thing. That is, you replace I2 by I1. So you get I1 by V1 as 1 by 2 more. And then so now we have found the parameters y11 and y12. Now to find the parameter y21 and y22, we have to short circuit the input port. So short circuiting the input port means we will be having V1 equal to 0. So here I have redrawn the circuit, that is given network is redrawn. So here we will be having the short circuit. So that is what is shown here. We have the short circuit over here. So the voltage value will be 0. We have just I1. So here we consider the current I1 in this loop, the I2 as it is we have considered. So I2 we have, and in the middle loop we consider the current to be I1 dash. You can give any naming just for our convenience. Now writing the equation. So from this side writing the equation in this loop. So first we have V2 is equal to, here I1 dash and I2 are in the same direction. So V2 is equal to 4 into I2 plus I1 dash. So we have this equation, V2 is equal to 4 I1 dash plus 4 I2. And in this second loop, that is this particular loop, so this is second loop, we have 2 into I1 dash plus 4 into I1 dash plus I2 plus 2 into, here I1 dash is in the upward direction and I1 is in the downward direction. So we have 2 into I1 dash minus I1. So with respect to that, if you simplify, you will get this equation. So 4I2 plus 8I1 dash minus 2I1 is equal to 0. That will be our second equation. Now considering this to be our third loop, our equation will be 4I1 plus 2I1 minus I1 dash equal to 0. So we get this equation, 3I1 minus 2I1 dash equal to 0. So now from this, we just want, that is Y12 is nothing but Y12 is I1 by V2. Y12 is I1 by V2. I1 by V2 and Y22 is I2 by V2. Okay. And Y22 is I2 by V2. So what we do is we try to replace I1 dash in terms of the other variables because we need to find Y12 and Y22. Okay, va? So now for that purpose, making all the substitutions, you will get Y12 is this one. So I1 by V2, that is minus 1 by 4 more, and I2 by V2 is 5 by 8 more. So we get all the parameters. Okay. So this is how we find the Y parameter, that is short circuiting the output port to find Y11 and Y21 and short circuiting the input port to find Y12 and Y22. Okay. Now we shall see the third problem. So here we are to find H parameters. So just for convenience, I have given the H parameter equations also, because all the time we cannot remember the formula as such to say which one is open circuited and which one is short circuited. So the H parameter equation, we have V1 is equal to H11I1 plus H12V2 and I2 is equal to H21I1 plus H22V2. So here to find H11 and H21, we should have the value of V2 to be 0. That means we should short circuit the output port. Okay. So here I have redrawn the circuit. Here actually you have this 2 ohm resistor as such. Here we will be making the short circuit. So this part we are making the short circuit. That's what this circuit is. So you have the 2 ohm, 4 ohm, this 2 ohm and the short circuit. So here please understand, you are not supposed to say this 4 ohm is in parallel with the short circuit, because you are having a 2 ohm resistor over here. Okay. So it is not a short circuit. It is 4 ohm and 2 ohm are actually in parallel. Okay. So as such, you can actually simplify the circuit and also try to find the answer, or otherwise directly give mesh equations for these and give the answer. Okay. So here we consider I1 to be in the clockwise direction and I2 to be in the anti-clockwise direction. So with this, we have 2 into I1 plus 4 into I1 plus I2 equal to V1. So we have this equation, V1 is equal to 6I1 plus 4I2. And for the second loop, we have 2I2 plus 4 into I1 plus I2. So we have this 4I1 plus 6I2 equal to 0. So now again from this thing, we can simplify things and find H11, because we have H11 to be V1 by I1 and H21 to be I2 by I1. So here this ratio I2 by I1 will give you H21 directly. So we have I2 by I1 as minus 2 by 3. And for V1 by I1, we need to make the substitution and find, and we got this as 10 by 3. Now to find H12 and H22. So H12 and H22 is, we have, this is the thing. So I1 should be made 0 over here. That is, we have to open circuit the input port. Okay. So thereby we will be having I1 value to be equal to 0. So open circuiting the input port. So there won't be any current in this 2 ohm resistor. So directly V1 will be the voltage drop across this 4 ohm resistor. So with respect to this, you will be having the equations 6I2 is equal to V2, because here we don't have any other current. Directly I2 current will be going through these two resistors. So we will be having 6I2 is equal to V2 and V1 is equal to 4I2. Okay. So from this, you get I2 by V2 as 1 by 6 more and V1 by V2 to be 2 by 3. Here you need to make the substitution, because we need the ratio for this thing. So we need to substitute for I2. So this will be V2 by 6. And so we get V1 by V2 to be 2 by 3. Okay. Like this, we find the H parameter values. Next, fourth problem is to obtain the ABCD parameter of the given network. So here also I have given the equations of ABCD parameter. So this will be helpful in finding A, B, C and D. So here we know to find A and C, we should open circuit the output port, and to find B and D, we should short circuit the output port. Thereby V2 will become 0. Okay. So by open circuiting the output port. So open circuiting now, you don't have this I2 current. Simply this part, till this part you will be having. Okay. So here this 1 ohm and 1 ohm will be in series. That will be in parallel to this 2 ohm. So you will be having this particular network. Okay. 1 ohm and 1 ohm in series. That will be the net circuit. So here considering the I1 current, you will be having V1 is equal to 2I1. And here I have considered the current in this 1 ohm resistor to be small I1. Okay. So by current division rule, so I1 current, the capital I1 current will be in this place. So this will be dividing in this 2 ohm resistor, this particular branch and this particular branch. Okay. So this current we have considered it as small I1. So small I1 is given as the capital I1 into 2 by the total resistance. So 2 by 4. Okay. This is by current division rule. This is applying current division rule. Okay. Therefore, we can say V2 as the voltage drop across this 1 ohm resistor. So I have this to be 1 into small I1. Okay. So substituting with capital I1, we get this expression. Now we can find A as, so A is V1 by V2. So dividing 1 by 2, we get the answer to be 4. Okay. And for C, it is I1 by V2. So directly from this equation, you can get it. So I1 by V2 is 2 ohm inverse. Okay. Then to find B and D. So B and D, I said we have to make this V2 0. So we have to short circuit the output port. So short circuiting the output port, we have the circuit like this. So here we have the 1 ohm in parallel to the short circuit. So this will not have any effect. And let us consider the current through this value to be small I2 in this direction. Okay. So now with respect to this, so here we have this 1 ohm will be in series with the parallel combination of 2 and 1 ohm. Okay, that is this 1 ohm and 2 ohm are in parallel. That is in series with this 1 ohm. So with respect to this, you will get this equation. V1 is equal to 1 by 1.667. That is 5 by 3 I1. And I2 current is, these are, that is capital I2 is opposite to this thing. So by applying current division rule, so here this you can consider one value and this to be another value. So by current division rule, small I2 will be equal to capital I1 into 2 by 3. Okay. So the capital I2 is opposite to that of this thing. So you will be having capital I2 is equal to minus I1 into 2 by 3. Okay. So substituting, you can find B to be. B is nothing but minus V1 by I2. So we get 2.5 ohms and D value is minus I1 by I2. So we get 1.5. Okay. That is ratio of current. So you don't have any unit over there. So these are the values for these parameters. Okay. Next, we shall see an example for interconnection of networks. Okay. So here you are given with two networks connected in series. So that is, this is a T network and this is a T network. And you are asked to find the Z parameters of the combination. So we know when you are interconnecting two networks in series, the Z parameter of the individual network can be added together to obtain the combined parameters Z parameter value. So for T network, yesterday I was mentioning, so you will be having Z11 to be the resistance value in the input port side. Okay, for Sabari's question, Y12 will not be equal to Z21 because it is Y parameter and this is Z parameter, right? That will not be equal. Maybe you are trying to ask whether Y12 is equal to Y21, I think. That will be equal when the network is actually reciprocal. In that case, you will be having Y12 equal to Y21. Always that parameter values need not be equal because always you cannot say a network to be reciprocal. So in such case, you won't be having it to be this thing. And for Sriharini, for finding Z12, so you have V1 is equal to Z11I1 plus Z12I2. So you need to actually make I1 0. That means you will be open circuiting the input port, not the output port. Okay. Z12 and Z22 will be obtained by open circuiting the input port. Z11 and Z21 will be obtained by open circuiting the output port. Okay. So to continue things, we have, yesterday I was mentioning in a T network, you can give Z11 value to be the addition of resistance, that is sum of resistance or impedance in the input port side. So we have Z11 to be 5 plus 10. So you will be having 15, and Z12 and Z21 will be the value of the common resistance or the impedance. So that value will be 10 ohms. And for Z22, it will be the resistance or impedance in the output port side. So you will be having 10 plus 15, 25 ohms. Similarly, for the second network, you will be having Z11 to be 15, Z12 and Z21 to be 5, and Z22 to be 25 ohms. So the combined network value will be simply addition of these, the corresponding Z11, Z12, Z21 and Z22 to be added. So you will be getting the answer like this. So this is actually by applying the interconnection rule, right? That is for when two networks are connected in series, the Z parameter values of the individual network can be added. So these are the problems we have seen today. So with this, I conclude today's presentation.